Hi and welcome to the companion tutorial for the Diode What's in a Box article. We're going to build a box used for basic electronic projects, and to do so we start by just selecting our box. So we have it there, select a little corner, and then we can adjust the dimensions. In this case we're going to be 71 by 51 to create our box. By default in Tinkercad it's already 20mm high, which is how much we want in this particular case. We need to create a second box. This box will become a hole that will actually go into the middle of this particular one. We just select the box tool here that's transparent, and this will actually create the hole. Now we need to change the dimensions. We're going to make this one 67. 3, 2, 1. We're going to make this one 67 via 47, which of course is fractionally smaller than our previous box, just to make sure that it fits inside and gives us some walls. Now once again, by default this is actually 20 high. We're going to make it 22 just to be a little bit fastidious. You don't really need to do it in this particular case. And we need to raise this up 2mm so it creates a bottom for this particular box. Select both boxes and then the align tool, and just click the centers, and we can see that we now have our boxes aligned, one on each other. Make sure they're both selected, and then click the group tool, and this will now create our box. So we can see here inside and the walls on top. So to create a basic lid, we repeat the process. This time we're only going to make this one 2mm high, and then we go for the same overall dimensions so they match, 71 and 51. Which if we flipped it over and put onto the top, we would actually see would fit with our particular . There we go. Now we need to add a slight instep here. So we will create a third box, and of course we will take the dimensions of this particular one to match what we did earlier. Bring it around here. Of course we don't want that high, we're just going to make it 4mm, just giving us a slight indent. And once again, there we go, and we can group them up together. Now if you look at these two ones, these are a very snug fit. The reality would be, depending on your printer and shrinkage, you would need to adjust that inner one ever so slightly in or out to get a fit that you would want. We printed this exactly as this was and found we just had to brush the Dremel around the edge to actually get it to fit into place. Now we need to make some small feet here, little supports that will actually hold our board up in place. We need to have a platform to support our project, in this case our Vero board. The holes in the Vero board are 5mm in diameter, so we'll need at least 6mm to support them. We'll make our supports 5mm high to give clearance to the soldering and wires that will run underneath. This of course will vary based on your board and wiring the project in place. As we'll be using 2.5mm screws, we will need to have 2mm holes. We will start by creating a cylinder, 6mm in diameter and 5mm high. So we just grab our cylinder here, drop it into place, and it of course is by default 20, so we're going to make it 5mm high, and we just change our dimensions here. There we go. Now of course we need our hole that's going in the middle there. These will be our 2mm holes. And we'll just go to our top view. We just need to align these two together. And this will create our support. So select your hole. We're going to move it up just 1mm, just to give a little bit of clearance, and then select the two again and group. We now have our basic foot support. So we were going to need 4 of these. We need to duplicate this. And again. And lay them out in a rough rectangle. And once you've laid these out, you can do a number of ways. You can actually drag each one over and place it into the box. This is probably the quick way. Once you have your items there, you actually select them as a pair and then use the align tool. We can see they're actually aligned. We do the same with the top two, and then we can check the align tool. Once again, they're aligned. These guys, they're aligned. They're aligned. Or the other way we can actually do this is actually by using the ruler tool. The ruler tool is over to the right. We have select our midpoint, and then you can base all your measurements off that. It does get a little bit more complex doing this way, but it allows you much more precise control. But we actually know that our things are in the right position. So I'm just going to shut the ruler down here, and then just move them all back over. Now, we spin around there, we can see our bits are ready to go. So if we want to move them over, bring this here, and this one here, and there you go. We have our basic box using Tinkercad. Now, Tinkercad is great, and for quick one-off jobs, it is really quick to get things done. However, OpenSCAD is another tool for designing 3D objects, but it lends a lot from programming. And if you've actually used any form of programmatic functioning before, you'll feel really at home in this environment. This is really good when it comes to dealing with things that are parametric. And what we mean by that is, say for instance, you wanted to build a set of bookshelves. Now, bookshelves occur with shelves at set intervals. So given the height of the shelves, we would actually need so many shelf inserts. By parametrics, would actually work all that for you. You just put in the height, it works the rest out. So in the case of the box that we're going to build today, we're going to look at basically making it quite simple and straightforward, and then actually allow us to change the variables to change that particular box whenever we need it. Now, I want to point out, within OpenSCAD, it has 3 primitive objects: the cube, the sphere, and the cylinder. Everything within it is basically made up from these 3 starting points. For the purposes today, we're actually going to be using the cube object. Now, I'm going to be using the word cube and box interchangeably as we go. So we actually will call the cube function to create our boxes as we go. So over here on the left-hand side, we've got our coding window. To create our basic first cube, we can just simply type cube, and then our parameters for this one, we're going to make it 50 on the X, 30 on the Y, and 20 on the Z. And then close it off, and then we hit our render button. There we go. Very simple, very straightforward, a cube or a box, depending on how you want to look at it. So we want to make this actually parametric. So we want to make it actually a little bit more programmatic. So I'm going to start by defining our variables. In this case, we're going to start with our length. We're going to make that 71, then our width, and this will be 51, and then our height. In this case, 20. In this case, 20. And our wall, in this case, will be 2 because you want to define the thickness of that. Your thickness may vary based on what you're actually doing. So we're going to define the outside of the box and then have the wall offset from within then. If we now went down and actually got our cube and we used our variables we've just set up the top here, and then we rerun it, we can see that's the cube that we've laid out in those particular dimensions up there. So we need to actually have a box within inside this particular box. So to create our second one and move it, we need to use translate. In the case of OpenSCAD, basically translate means to move a given distance. So in this case, we're going to move our box, which is going to be the child of this particular command, the distance of the wall in the 3 ways. So now we can do our second cube, and we're going to do a couple of things here that make it a little bit trickier than normal, but this is where the joy, and I say the word joy, of the parametrics actually comes into it. So our cube needs to have a few differences there. So it needs to be slightly smaller. So its overall length will be length minus wall times 2, because there's 2 walls, so we want to overall shorten it. Now our width is the same. We're going to shorten it by our wall, and our height actually doesn't change in this particular case. So if we render this one, so if we render this, you can see, of course, it's popped up by that 2, that is, of course, our wall height. That's great, except we actually want that to be the whole. So in the case of OpenSCAD, so we call the difference function, and we enclose everything inside its curly braces. Then we render it, and there we go. There's the bottom of our box. It's quite straightforward, and by adjusting any of these parametrics up the top, we can have the box that we would want or we need. So we need to create a lid, which is our next part. So we need to now make our top for our box or our lid. This is going to be slightly different, very similar thing. We're going to have 2 cubes, but we're actually going to do a union this time, which means join them together as opposed to a difference. Firstly, though, we need to move everything away. So we're going to use translate again to actually move everything. And of course, as our parametrics change, our distances will change for our objects. So we just need to specify which particular objects we'll be changing. Remember that, of course, it's case sensitive. So if you call something width with a uppercase W, it won't actually read it when you attempt to do it and it's a lowercase. Create a little bit of problem. You will get a compiler warning, which will make it easier for you to sort out. But there we go. There's our translate, which of course means to move. So now we want to do our new cubes. We're going to run a union. So we do union. There's our second union one, just to make sure that we're doing it. We start by doing our cube, and we use our length, width, and wall for our dimensions in this particular case. This will actually offset it by the margin that we need. We then go to translate again because we need to slightly move this part of the box, and we will be doing it for the similar as we did before, for the wall height, and the wall width, and then 0. And then finally, now we have our last cube to put in to actually make our box sit nice and snug within the rest of it. This is our little instep. So we're going to start out with our cube, and of course we put our length in, and this is minus the wall width times 2, and then we have our width minus the wall times 2, and finally the wall plus 2 to create our little instep, and close our brackets off, and then we render it. And then we can see we have our little step. Now, once again, this is a very close fit. So depending on the tolerance of your printer itself and the weight. But the beauty of this is we can now go and basically make it whatever we need to fit our particular purposes here. So we can make some big long cases, small cases, whatever our particular need may be. And do there, just re-render it, and away we go. And then when you're done, just hit the STL and you can straight to your particular slicer software.